All right. Worksheet 1219, AB number 8. We just did AB number 8 multiple choice, but this is AB number 8 for response. So these are specifically a graphing calculator. Now, the thing to remember on the AP test is that you generally get 2 graphing calculator for response out of 6. They're the first 2 you do. You get 30 minutes, and then your graphing calculator has to be put away, but you can still work on. So the question you ask yourself, especially if you feel like time's going to be an issue, is do I need a graphing calculator to do this part of this problem? If not, leave some room, skip it, go on the next one, and then come back after you've lost your time with your calculator, do the problems that you can't do. Do the problems you can do without a graphing calculator. So this function is a kind of complicated function. R is a shaded region in the second quadrant, bounded be the shaded region in the second quadrant. So that's just that one. S is the shaded region over here between the graph F and the tangent line to F at x equals 0, which looks like that's 0, 3. You could confirm if you plug 0 into here, you get 3. So that's the point tangency. So it says find the area of R. Now to find the area of R, we need to, we're just integrating the function fx, so that's good enough. You have a calculator, so you can just type that. You can just write that down as your setup. And I'm probably going to be using this a lot, so I'm going to type this into my y menu, x to the third divided by 4 minus x squared divided by 3 minus x divided by 2 plus 3 cosine x, double, triple check it. Might as well graph it too, because, by the way, one of the things that we need to do is we got to find the upper limit's 0, but the lower limit is whatever this x-intercept is. So let's go to window. We always go to window before we graph anything, and I think we have a pretty good idea of what the window should be based off of the sketch they've given us. So I'd say -2 to 4, and the y, we could say -2 to 4. Graph it. Let's see what happens. So this will also help you, I guess, double check that you entered it in correctly. Nice side effect of it. Okay, now it doesn't draw the tangent line because we don't have the equation for it, but we'll talk about it later. Right now, we're just concerned about getting this x-intercept right here. So we're going to do second calc, 0. It's between -2 and -1. Guess -1.3. Let's do its job. It is. Now I'm going to write this over here just as something helpful. -1.373122. Now write extra decimals because you're going to use this to find another answer. So that's going to be the lower limit, -1.373122. And this is good enough for the setup. Now, the point breakdown here is going to be 2, 4, 3. So 1 point for the setup and then 1 point for the answer. Now, the answer, you could integrate it here, but why not? Second calc, I usually don't do it because it takes longer and you can only do one curve at a time, which is all we're doing this time. I'm going to say -1.373122. Never, select the limits by just using the cursor. Type it in to 0. And it's kind of cool because it shades it in. Kind of confirms, I guess, that you did the right area. And the answer is 2.903. Rounded truncated through decimal places. That's 1 point. So not too bad. B says find the volume of the solid generated when R is rotated about the horizontal line y equals -2. So that would be here, y equals -2. So I'm going to sketch it. Doesn't need to be perfect, but right. So that's the solid of revolution, and we're trying to find the volume of it. So we could do vertical slices, and we get disc washers, or we could try and do horizontal slices and get shells. I mean, I think disc washers looks like the thing that's going to make the most sense. So the volume of one of these slices, there's the circle times the thickness. So it's just pi r squared dx minus pi little r squared dx for the hole in the middle. Then we're going to integrate them. So the limits are going to be using that same value we just found, negative 1.373122 to 0. So the big radius is here, and this is the little radius. The big radius is y top minus y bottom. Y top is the y value along that curve in terms of x, which is f of x for short. So you don't have to write it all the way out. Minus y bottom is negative 2. And then you go square it. Dx minus pi, negative 1.373122 to 0. The top, little r is y top minus y bottom. Y top is 0 minus y bottom is negative 2 squared dx. So you get a positive radius. The order matters. Even if you mess up the order and you square them, you get the right answer, you lose most of the points for your setup. So 1 point for the limits and the constant, which would be for both of these. If you separate them, you could put them into the same integral if you want. And then 2 points for the integrand. 2 points for the integrand. The integrand is what's inside the integral. And then just 1 point for your final answer. So this setup is crucial. You need to make sure you show it. Now, I'm not going to do this on that graph screen. That wouldn't really make sense. I'm going to do it here. I'm going to say pi, math 9. I could go parentheses, vars, y vars function y1 plus 2, close parentheses, squared, comma x, comma, negative 1.373122, comma 0, close, minus pi, math 9. The radius of, the inside of that one's going to be just positive 4, comma x, comma, negative 1.373122, comma 0. And this should do it. So hopefully you're getting pretty good and quick at calculating these. So you get 59.361 round truncated 3 decimal place accuracy. Comes out the same. That's 1 point. So most of the points are for your setup. So even if you run out of time with your graphing calculator and you hadn't done this one, you could get 3 out of 4 points, right? And I guess as long as you had this intersection. If you didn't have this intersection, make something up. I mean, you can guess about what it is, and you would just lose the point for that. C, write but do not evaluate an integral expression that can be used to find the area of S. Now, S is the area between two curves. And I think we're going to want to do y top minus y bottom. Now, y top is this line, y bottom is the curve we already have. We got 2 issues to figure out. We got to figure out the equation of this line, and then we got to figure out the intersection of those two, because that's going to be a limit. So the equation of the tangent line, there's a trick on your calculator. You could go to your graph, and you could go to the draw menu under program, second program, draw, and you could go to number 5, tangent, and it brings you to the graph screen, and you say, well, where do you want the tangent line drawn to? You say at x equals 0, and it draws it, which is kind of cool, and it gives you the equation down here of it. So the tangent line equation is y equals negative 0.49999959, and the 7x plus 3. Now, you're not going to be able to find the intersection between these curves yet, because if you go to the y menu, it's not there yet. Now, you could also find the tangent line the good old-fashioned way of saying, well, I have a point, 0, 3, right? I need the derivative, so I'm going to find f prime of x, which you could do on your calculator, or you could do by hand. 3x squared over 4 minus 2x over 3 minus 1/2 minus 3 sine x. And you say, well, I want the derivative at 0. Plug zeros into all these. They all drop out. Even sine of 0 is 0. You get a negative 1/2. So the equation of tangent line is going to be y minus 3 equals negative 1/2 x minus 0. Slope intercept form, be negative 1/2 x plus 3. Now the calculator didn't do it so perfectly, because calculators kind of use estimation techniques. does a pretty good job. Either way you do it, you need to enter that equation into your menu, negative 0.5x plus 3, graph it, and it won't look like it's doing anything new because it's just grabbing over the top of that other line that you drew if you did that. And we got to find this intersection right here. Second, calculate. Number 5, intersect. First curve, second curve, and then guess, because if you just hit enter right now, it's going to find the intersection right there. We want to find this intersection. So I'm going to say 3.5. Looks like a good close guess. And I'm going to write it on my picture just for my own reference. It is 3.389867, 1.30506662. So our setup to find the area is going to be the integral of 0 to 3.3898677. Top curve is the tangent line, negative 1/2 x plus 3, if that's what you did. If you used your calculator, I'd write that one in there. Minus the other equation, which I'm just going to write fx. Or you could write the whole thing in, but you better put parentheses around it. And there you go, you're done. 1 point for the limits. 1 point for the integrand. 1 point for the getting the equation of tangent line correct. So that was a good one. You guys should have tried these already. Should have tried the one on the back if you haven't tried it yet. And let's graph and calculate a problem. A little motion. You have to learn your motion. Motion 1 dimension. So particle moves along the x-axis. This is its velocity times 0. The position is at. So x0 equals 1. So I give you initial condition. A says find the acceleration of the particle at time 2. The acceleration. Okay, so acceleration at time 2 is going to be the derivative of velocity at time 2, right? Now, I could go ahead and calculate that derivative by hand if I want. It's not going to be that pretty. It's going to have a product rule, trig, chain rule, power rule. Probably be nicer to just let my calculator do it. Now, I'm going to go and put it in the Y menu because I might need to use it multiple times. So I'm going to negative, parentheses, x plus 1, sine of x squared divided by 2. I'm not going to graph it. Go back to the home screen. Math 8, that's derivative. Vars y, vars function y1, comma x, comma 2. Done. Now doing that by hand would have been a lot more work. Now show this stuff right here. Show your setup. A equals v prime, because you got to like kind of connect it to what they gave you. And then you don't have to show how you do it on your calculator. It says, is the speed of the particle increasing? So that's asking you, is it speeding up? Now, if it said velocity increasing, you'd say yes, because acceleration is positive, because acceleration is, if the velocity is increasing, it means the derivative velocity is positive. Speed, though, doesn't care about direction, so you have to consider that they're in the same direction. Why or why not? So we have one thing that we need to help us, but now we need the velocity at 2. I already have this equation in my graphing calculator Y menu, so a quick way is to go to the table and type 2 in there, and it's negative 2.727. And so that one's negative, and this one's positive, so it is speed is decreasing. So we're going to say the speed of the particle is decreasing at t equals 2. Since acceleration at time 2 is positive and the velocity at time 2 is negative, they are in opposite directions. So you might want to put that, because maybe it might seem that you think that acceleration has to be positive, velocity has to be negative for this to be true, but they just got to be different. So, anyways, okay. B says, find all the times t in the open interval where the particle changes direction, justify your answer. Now, the way you're going to justify the particle change direction is you're going to say the velocity changes from positive to negative or negative to positive. And it'd be good if you're as specific as possible. And the easiest way to find this, now, you could try and solve this by hand. I'm sure you can do it. It's going to be a lot easier if we graph it. Now, we're only interested in 0 to 3, so I'm going to go window, 0 to 3. I'm going to do zoom fit. Get a quick graph of this velocity curve. And let's see, it might hit 0 right there, and then it definitely goes there. You want to make sure, double make sure that that actually is at 0. So the way I do that is I say and calculate 0, and I say, let's look from 0 to say 1 and guess at 0.5. So I'm going to guess there, and it's going to find the closest one. And if it gives me 0, then I know there wasn't another one in between it. Okay, so that's good. Then we need to find this one. Second, calculate 0. It's between 2 and 3, guess 2.5. And that's, so what we do, this is probably some good stuff to write down, is we're going to take the velocity equation and we're going to set it equal to 0. Or potentially undefined, which I don't think usually happens on real world motion problems. And we get the times. Let's write them down, 0 and 2.506. And then it's negative here and positive here. So we just need to say this. You could sketch this graph if you want, but that's not going to get you points. So we're going to say the particle changes direction at time t equals 2.506 or 507 since velocity is negative on the interval directly to the right on 0 to 2.506 and velocity is positive on the interval directly to the right, 2.506 to 3. Now, don't say t is just greater than 2.506 and t is less than, because that's going outside the boundaries of what we even looked at the graph. So you don't know, and we don't care. Point-wise, 2, 2, 3, 2. So 1 point for the acceleration, 1 point for deciding if it's speeding up or slowing down, and the reason. This is 2 points. 1 point for the answer, and then 1 point for the justification, explanation. C, find the total distance traveled. You guys should love this equation, this question. So in general, and even next year in two-dimensional motion, in BC, distance, total distance is the integral of speed. Now, in one-dimensional motion, that's the integral of the absolute value of velocity. And we're saying from 0 to 3, this is what you need for sure to get all the points. This is where 3 points, the limits are a point, the integrand is a point, and the answer is a point. You don't have those absolute values, don't get it. So I'm going to do on the home screen, Math 9. I'm going to go to Math menu, go to num absolute value. I'm going to do vars, yvars function, y1, close the absolute values, comma x, comma 0, comma 3. And my calculator will do it all for me. Take a deep breath. I don't know, I'm enjoying the downtime. I don't have to do the work myself. The calculator's going to do it faster than me. And give me the right answer, 4.333 or 4.334. That's 1 point. Got to show the setups. D. Now, if they said displacement, you do the integral of just velocity. D says, during the time interval, what is the greatest distance between the particle and the origin? Show the work that leads your answer. So we're looking for greatest distance from the origin. Well, wouldn't that be, that'd be a max absolute value of x position. This is an absolute max problem. You should be using extreme value theorem. That's going to be the justification. The endpoints were given to you, which is nice. And then you got to find the critical points. You guys should be so good at extreme value theorem and good at showing the work. Really nice. So we got to do x prime of t, which is velocity, set it equal to 0 undefined. You need to write this down. This is often worth points right here. You need to write it down. You don't get the points even if you use it. This is calculus right here. Now, we already found these earlier. So we can write them down, 0 and 2.50. Now I'm wishing I'd written down more decimals. So I'm going to go back and recalculate it, and that's what I get for not just writing them all down earlier. I should have. You might have to use them again, and you need more than 3 decimals in your work for other answers. Now we got our critical points. So now we're going to make a table, and we're going to put time in, and endpoints and critical points, and we're going to plug them into x. Now here's the problem. We don't have x. And if you try and integrate this by hand to get the x equation, you can't. You can't integrate that. Sorry. Even if you could, you don't want to because you have a calculator. So we want to, if you have the derivative and you have a known point, they told you that x0 was 1, right? And you want to find x at another point. Fundamental theorem of calculus part 1. Fundamental theorem of calculus part 1. We use this all the time. That says, well, if you integrate the derivative of something, you're just going to get the function. And so if we go from the known point 0 to some other point t, you're going to get xt minus x0. So xt equals x0 plus the integral from 0 to t of velocity is what we have, right, for x prime. So, and x0 was 1. No absolute value in the velocity here. Now, if I plug 0 in, I get 1, which makes sense. Then I'm going to use my calculator to do this. So I'm going to say, all right, 1 plus math 9 bars, y bars function y1, comma x, comma 0, comma 2.50668283. That should give me the next value in the table, negative 2.265482. Then I'm going to do it again. I don't want to retype all that, so I say second enter. Go back up here and change the 2 to just 3. Delete, 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 delete. Enter. That's negative 1.1971471. Now, we actually want absolute value here, right? So we're not looking for the max x, we're looking for the max distance. So we take the absolute values of this, and which one's the biggest absolute value right there? That's the max distance from the origin. So you could be to the left of the origin and be the furthest away from it. So we're going to say the greatest distance between the particle and the origin is 2.265 positive at time t equals 2.506 or 2.507. There's no units on this problem. By extreme value theorem, write it all the way out. You got to name it. And how does that theorem work? Checking endpoints and critical points. So there we go. So this was good worksheet practicing using your calculator. Like fundamental theorem of mechanics part 1 comes in so often on calculator problems when they give you the derivative of anything. It doesn't have to be motion, it can be whatever. You got to recognize when to use it and allow your calculator to do that hard work for you. Either to do it instead of you doing it by hand, or in this case, you just couldn't do it. And if you, whatever you did, it wouldn't make sense. You wouldn't get any points. So, all right.